Hello, welcome back to Cracking the Cryptic. Now, connected with the channel, there is a Discord server where a lot of people get together and discuss Sudoku and all sorts of stuff. There is a Patreon chat channel where you can talk about how to solve the puzzles that appear on Patreon. I'll get to those in a moment. There's a lot of just sort of general chat channels. There's pencil puzzles and Sudoku. You can submit your own Sudokus for, well, analysis is maybe too strong, but for views on how they are. And we have been recommended this puzzle that has recently appeared there by Jacob Kadar. And I think Jacob said it was their first puzzle. So nonetheless, it's been recommended to us to try it on the channel, and it's called Dizzy Dancing. And I'm going to give it a go today. We'll see how it goes. There are some very implausible cage totals in the middle box. I will hope that the rules account for those. And I'm going to try the puzzle and we'll see how it goes. Now, I mentioned that on Patreon there are some extra puzzles. Those tend to fall into the Patreon monthly reward, which this month is Put Out More Flags, a set of 7 9x9 Sudokus themed on various flags from around the world that use some of the shapes and colours in those flags and provide quite a tough challenge. So do give that a go. If you were to win, i.e. get your solution in by the 20th of the month and get drawn out of the hat, the opportunity would be there for you to collaborate with Simon on a solve on the channel. So do consider that. Also on Patreon, for $2 a month subscribers, there are crosswords, both myself and Simon tackling some tricky listeners, and myself doing the Times Monthly Club special. So if you like the cryptic stuff, there's a lot there. If you like the New York Times game Connections, I play that every day as well, and you can see that there to go with my Wordle in a Minute on the channel and Simon's masterclass, of course. So much content that we try and bring you. And then there's even more in all of our apps, which do feature Killer Sudoku, and Line Sudoku and Fog of War and the Worms. So check everything out. The links are all under the video, but the first link is to this puzzle. It's called Dizzy Dancing, as I say, and the rules are as follows. Normal Sudoku rules apply. That means put 1 to 9 in every row, column, and 3x3 box. And identical digits cannot be a chess king's move apart. So these two couldn't be identical digits because they're within 1 of each other diagonally. I mean, the other moves for a chess king are orthogonal, and Sudoku rules take care of avoiding identical digits there. Now, squares indicate even numbers and circles indicate odd numbers. Here it comes. Here comes the explanation. First of all, digits along the marked diagonal can't repeat. So that's a set of the digits 1 to 9, 2 of which are provided already. But in the central box, digits have either their values doubled or halved, and the values in a cage in this puzzle are the values that are either doubled or halved, and they add up to the value given. So this 4 cells that add up to 45, some of those digits may be doubled and some of them may be halved to get that value. That's really weird. But that's how it works. So outside box 5, things aren't doubled and halved. So these will be a normal 9 and 8 cage, I guess. Give it a try on that first link under the video. I'm going to start now. Let's get cracking. What on earth do we do? I mean, I could do the boring stuff first and say there's a 6 in one of those cells, not the odd one, and there's a 7 in one of those two, not the even one there. But really, I mean, there's a 1 in this 8 cage, and actually that's not on the square. Oh, there's a 3 in this cage, because if there's not a 6 in a 9 cage, you can't have 6, 2, 1, and the other 2 possibilities are 1, 3, 5. Actually, that won't fly either, because this is an even digit. 1, 3, 5 are all odd. So this must be a 2, 3, 4 cage, and the central digit is not 3 because it's a square and therefore even. So there's a start, but none of it is going to stop me having to work out what's going on in the middle box. So I'm presuming, I never did maths beyond the age of 16. But I think we're looking at simultaneous equations somehow here. Now, how is this going to work? And this may not be how you have to do it, but it's how I'm going to think about it. So, first of all, I'll share a secret with you, that the sum of every row, column and box in a Sudoku is always the same. We know the answer. It's always 45. Now, it won't be the same for this box, obviously, because some of the digits will be doubled and some will be halved. However, the sum of the digits in the box will be 45, because it's the digits 1 to 9. The sum of the digits, not their values. Now, if I take out that 5, the sum of the digits in these cells, these yellow cells, is 40. I know that because I know that the sum of the digits in the box is 45 and we're not including the 5. So the sum of the digits in these cages is 40. But the sum of the values in those cages is 45 plus 15 plus 8 is 68. Okay, so I'm going to designate an X and a Y. And I think, so I'm going to use an area of this grid as aide-memoire while I try and do these simultaneous equations. So I think that if X is the digits that are going to get doubled and Y is the digits that are going to get halved, surely I can write that X plus Y equals 40. X plus Y equals 40. That's the simple bit. The harder bit is that if X is the digits that are going to get doubled, then 2X plus half Y, I don't know how to, I'm going to just remove this stuff for a moment. Half Y, I don't know how to show that. I can't show 0.5Y. Well, imagine that says 0.5Y. So double the value of the digits that are going to be doubled and half the value of the digits going to be halved is going to give us 68. So now I want to reconcile these two simultaneous equations. So let's start by saying if X plus Y equals 40, then X equals 40 minus Y. And 2X must equal 80 minus 2Y. So we could substitute that 2X, 80 minus 2Y equals, plus half Y. Well, that's going to give us 1.5Y. 80 minus 1.5Y equals 68. And that means that 12 equals, I'm moving the 68 across the equation and therefore it gets a minus. I'm moving the minus 1.5Y across and therefore it becomes plus. And that's going to mean that 12 equals 1.5Y. 1.5Y. So if I double those up, that is 24 equals 3Y, which means that 8 equals Y. And since Y plus X equal 40, Y is 8, X is 32, and that means that the number of, or the sum of the digits here that are going to get doubled is 32. The sum of the digits that are going to get halved is 8. And that is how we're going to get values of 68 and digits adding up to 40. So the digits that are going to get halved are either a single 8, a pair of 1, 7 or 2, 6 that don't involve 5, or 3 digits that could be 1, 3, 4. So the halved digits add up to 8. Oh, hang on. That may all have been very unnecessary. It's only 6 minutes out of your time, or 5 since I've been doing the maths. 2 of these bloomin' totals are odd. That's difficult. If you, like this 45 cage, it's mostly going to be double digits because it's such a huge number for 4 cells. However, it's not all going to be doubled digits because then it would be even. So there must be at least one not doubled digit, one halved digit in this cage instead. And there must be one halved digit in this odd cage of 15 as well. Oh, in fact, that is going to be very limited. So what can the halved digit be? You could halve a 2 and get a 1 and double a 7. So this could be a 2-7 pair. Or, well, you can't halve 4 because then the 13 wouldn't come from a double digit. So you could halve 6 to get 3. No, then you'd be doubling 6 to get the other 12. Oh, this cage is just a 2-7 cage. That's all it can be. Isn't that strange? Maybe it's not strange to you. It's strange to me. No, hang on. I've got it the wrong way round. Have I? No, I've got it the right way round. It's either double 6 and halved 6, but that would involve repeated 6. Or it's doubled 7 and halved 2. And that's it. Right. Oh, by the way, this cage is going to be made up of, at least the thing I did at the beginning told me that there were only going to be 1, 2 or 3 halved digits involved. Now, we know that it's at least 2 because both of these cages need one. But we also know that this digit, this cage, I was going to say it can't have a third half digit because it would need a fourth. That's not true. I'm talking absolute bobbins. Oh, do we know something funny is up with it? From these digits, it can't be a natural cage. That's extraordinary. Is that true? No, it can't be true. Oh, it could be both of them being doubled. There is no such thing as a natural cage. Digits are either doubled or halved. Actually, do you know what I finally understood from that first delve into the calculations required for this 15 cage? What I finally understood is that you can't just have that if you applied 4 or 8 in this cage, you couldn't, as a halved digit, it wouldn't work at all. Because 4 would halve to the number 2, and then when you double the other digits, you'd still be on an even total, and 8 would halve to the number 4. So 6 must be in this cage, and it must be in there as a halved digit. And in fact, I did calculate that the halved digits y were going to equal 8. So there are a 6 there and a 2 there, and that's it. Everything else is being doubled. So everything in this cage is being doubled, so it contains 1 and 3. And everything in this cage that isn't 6 is being doubled, and those digits must be 4, 8, 9. 4 plus 8 plus 9 equals 21, doubled to give 42, and then half of 6 makes us up to 45, and that is it. Right. Now, do you know what I forgot to get out at the beginning? Was my Mr. King, who reminds me when I forget about the King's move. Somehow I've remembered to get him out now. No, that's the Queen. Here's Mr. King, who's going to sit here in case I forget again and tell me not to forget the king's move. But I've been doing maths and I haven't had time to think about that. But I am going to think about it now because all of these cells see that cell using the king's move. One of these cells is a 4. And whichever one it is, this digit can't be a 4 because it's either in the same row or a king's move away. I mean, that's thrilling, isn't it? Anyway, this cage, I removed the 1, having deduced there had to be a 1 in it. Actually, this even digit is going to be 2 or 4, and the other digits are going to be 1, 3 or 1, 5. And one of these is a 3. So now the 6 sees that cell on the diagonals. There's a lot of things to remember in this puzzle. I haven't even got to the odds and evens really, but we've had to deal with the maths here. We've got to remember the king's move, and we've got to remember the diagonal too. So no repeats on the diagonal means that's not a 6, and now this is 6. There's my first digit in the grid after 12 minutes, about 5 of which was probably wasted doing maths, but there we go. I get overexcited sometimes. Now, let's try and do Sudoku. Oh, this digit sees a 1-3 pair and 7, and it's odd, so that's 5 or 9. This one sees a 2 in one of those cells, either by king's move or normally, and it sees 6, so that's 4 or 8. This is a very poor way of doing it. Let me try and work out. There's 2 and 4 are in that group of cells, and 6 is there. This even one must be an 8. That one in the corner is 2 or 4, and that is now a pair on the diagonal. That's helpful in 2 ways. The first is that it resolves this cell entirely, which makes it a 7, because once 2 and 4 have both appeared on the diagonal in those 2 cells, this one can't be another 2. That 7 stops this being a 7 and places a 7. And this can't be a 4. That's the second way, because 2 and 4 are both looking at it. So on the diagonal now, 5, 7, 6, 2 and 4. The other digits we have to place are 1, 3, 8 and 9. These 2 odd cells are selected from 1, 3 and 9. And oh no, that's one of 8 or 9. I was going to whack in an 8 in the bottom, but we can't do that yet. Right. Might be worth marking up the even digits. It might be a bit dull though. Oh, we've got one more even digit to go in this column, so it's there, 4 or 8. Everything else is odd. And we've seen 1, 5, so that one's 3 or 9. These are from 3, 7, 9. We've got a 2, 4 pair here and a 2, 4 pair including that. These are from, no, that might not be even. 7, 5, 6, 1, 3, 9. No, I don't really know. Okay, so I've got to use the king's move a bit more. I haven't been using it, so let's think about that. This is odd because it sees all the, oh, in fact, everything else in this column is odd. So let's mark that. And this digit sees 7. Oh, is that, and 3 in that box. So it's 1, 5 or 9. That one also sees 7 and 3. And that sees 7. So there's only one place for 7 in this column. I finally worked that out. There it is. That's not a 7. This is 1 or 9. That one can't be a 5. Oh, I might as well give in to my passions and mark all the even cells. Right, they're all even, and that's quite a lot of them. Let's do all of these as odd. All of the circles are odd. Oh, we've got some givens as well. Those 2 are both odd. Those 2 are both odd. And that one. So all of those are definitely odd. That's even. That's odd. Right, I mean, that is quite a comprehensive start. We can fill this in by adding up 5 oranges, so that's blue. We've got 5 oranges and 4 blues in every row and column. This box needs 2 more blue, and that's all the blues for the row. So those are orange, and that can't be 6, and this must be 6. It does help a bit if you schematize the colouring. That's a 4, that's not a 4, this must be a 4 now. That makes this a 2 on the diagonal, that puts 4 in the corner. Oh, it was worth doing. Goodness me, it's extraordinary. Don't know where the stuttering came from. It's extraordinary how helpful it can actually be. Now this digit sees 7 and both that 1 and 3. So this is 5 or 9. It's not 5, it's 9. It's naked single. That sees this cell and makes it 8. And that's going to impact our colouring a bit. Or maybe not. It's going to impact the diagonal. It's going to make this odd and either 1, 3 or 9. Now, this sees 1, 3 and 7 in the column, so that's 5 or 9. And that is very... Oh no, I was going to say it can't be 5. Oh, it's true. Okay, this cage, since we got the 2 in it, has to have a 1 and 5 in. And it is true that this cell now can't be 5, because whichever of those is 5, it's a king's move away. So I'm going to put a 9 in there. And that's 3, and that's 7, and we're underway now. That's a 9, that's 5, that's 3. In this column, we've got a 4-9 pair, so we've got a 2 there. These are a 2-6 pair. I'm going to colour them blue. Might not need the colouring much anymore, but we've got an 8 to place down in one of these. That 2 on the king's move makes that a 6. Those are not resolved, but they do say this can't be a 3. That digit sees a 6 on the king's move, and that one sees a 6 in the vertical. So this is 6 in the row. That's 2 or 4. We need a 4 in one of these 2 positions by Sudoku, and a 7 in row 8 is done and goes orange. And that's going to put a 7 in one of these 2 cells. 7 in box 6 is in one of those 2, and I can't actually resolve those. That 9 is looking at this cell and making it a 1. That gives us 3 and 1 there, and this is not a 1, and that's not a 1. This is also not a 9 at the top, so that's a 5. That's a 9. We've got 3 and 5 to go in the row. That 9 sees this cell, so 4 and 9 there. Might as well colour away. Oh look, I've got all 4 blues in row 6, and that's going to solve this 9 cage. That odd digit is a 3. This even one below it is a 2. These 2, well, this one sees 4, 6 and 8, so that's a 2. That's a 4. Might be able to finish all the even digits now. Lots of them are getting freed up. One of those is the last even digit in the box, which is a 2. These 2 are both even, so they don't include 7. That's a 6-8 pair. There's a 2 over here somewhere. There could still be a 7 there, though. In fact, there must be a 7 there. There is a 7-2 pair here. So that one's the 7, and that one's the 2. Again, let's whip the palette out and paint them up. That's a 7. This is a 5. I can see that now. That's a 3. This digit is 1 or 5. And it's flowing together very nicely now. 6, 8, 2. We need a 4 in this column, and it can't be here, so it's down here at the bottom. That's a 4. This one is an 8 because it sees a 6 in its column. The 6 in the box has to be there. This cell goes orange. We've got all 5 orange in column 2, and that gives us all 4 blue in box 1. And now we've only got a very few cells left to colour, and I think I can handle the pressure of that. This is an 8. It's very specifically, that's the last one in its column. And here we need an even and an odd. And we're going to be done with the colouring. Good. Now, I can finish off the even digits. 2 there, that's a 6. Just box 1 to do. That's a 4. 2 and 8. That's all the evens done. Right, that 1-5 pair are looking at this cell using the king's move, and that also sees 9 and 7, so it's a 3. Those digits on the diagonal are not 3, so that one is. They are instead 1, 9, so this is 5. That's 1, that's 5. Can't sort the 1 and 9 yet. I've got 5 and 9 to go in row 2. 1 and 3 to go in box 1. 9 and 1 in box 3. Then I can come down to the bottom and do 5, 9, 3, 1. That sorts out the corner. 9, 1. And 2 digits left to go, and there we go. It's a very neat puzzle, dizzy dancing. I don't know, do let me know how you got on with the middle box particularly, because I suppose you could just work out how to do the 15 cage. Maybe you could just do the maths on the 45 cage then. 9, 8, yeah, you probably can. That's, I imagine, the simpler way to go about this, is work out there's only one way to pop. It's the fact that these two are odd. I didn't really work on that. I worked on the total, which was foolish. Yeah, okay, you don't need to tell me how you did it. You probably did it by working out the 2 digits that go in that cage, working out what digits could possibly go in this cage, and then deducing the 8 cage as the kind of remainder. It's a lovely idea. I mean, I like that the funky values were confined. That's good, because it makes the rest of the puzzle a little bit more approachable, and I like that. So thank you very much for watching. Absolute pleasure to be with you, as always, of an evening, and I do hope you will tune in to one of our videos at least tomorrow. From Cracking the Cryptic, it's bye for now.